I'll try to make it really fast and short. So Dr. Vargas and I were working on the presentation. So we use the same template, but I promise you it's a different presentation here, all right? So anyways, we will tell you a little bit about the advanced topics concentration. As Dr. Rashid said, it's actually when you don't have a concentration, so you will end up in the advanced topics and concentration, all right? So it was a very tough job to do. That's why I will have Dr. Harish here to help me, trying to convince you that advanced topics are actually, it's not like when you don't know what to do, it's actually when you really know what you want, but it's multidisciplinary in a way that you can combine more than one concentration, all right? So that's why just a brief introduction, all right? And that's how we view this advanced topics. So advanced topics requires knowledge in several EE fields. It's unlike the control or the electrodynamics or other fields. Basically here you will know everything or a little bit from everything, then try to come up with an interdisciplinary projects, and all this knowledge, all these advanced topics that you studied in different fields, different classes, they will help you shed light on some contemporary applications so that you can apply the theory you learned to solve some real life problems, all right? And now hopefully we will show you some of the interesting and exciting ideas and things that you can do with the concentration like that, which is the advanced topics in EE, all right? So what you will learn when you are in the advanced topics, of course, you will also learn these if you are in other concentrations, but mainly if you focus on, or if you are part of the advanced topics concentration, you will definitely learn a lot about digital image processing. And when we say image processing, you will learn about image enhancements, feature extractions, and all of these fancy things that you can do with images these days. You will learn about signals processing, so you will learn DSP, you will learn how to design filters, how to do a little bit about sampling theorem, analog to digital, digital to analog, and all of these other things that you can do. Satellite communications, you will learn about orbits, how to put a satellite in orbit, what are the different orbits that we have, what's a satellite, how to design an uplink and downlink, and how to make the satellite communicate with an Earth station, basically, all right? So this will be hopefully a course that we'll offer soon. Also, software-defined radio. This is kind of the new trend in transmitting and receiving, where you don't have a fixed frequency. You can actually change the frequency in the transmitter and receiver, and that's why you will learn about transmitters, receivers, and cognitive signal processing in general. Also, we are planning on radar course, so you'll learn about radar applications. And you'll see that we can use radar for object detection, weather applications, these Doppler weather radar, and of course, autonomous vehicle. You all know that we have the Advanced Mobility Institute here at Florida Poly. It's one of the most advanced institutes that deals with self-driving cars and autonomous vehicles. So we are part of that institution, and we have lots of collaboration with them. So we have lots of projects ongoing, and hopefully this will be helpful to you in case you decide to do something related to that. All right? All right. All right. So what you can do when you study all of these very interesting topics, you can be design or test engineer, you can be a telecommunication engineer, algorithms engineer, DSP engineer, RF or microwave engineer, you can work as a communication system, calibration and validation engineer, or radar signal processing engineer. So basically, as you can see here, most of the things that are related to application of the theory, and then how you can deal with the data acquisition system, the sensor, the signal processing part, and then the data analysis, and then if you have more than one sensor, the data fusion. This is basically everything that you will learn in this advanced topics in electrical engineering. All right? Now, new technologies around the corner. I'll probably here invite my helper, Dr. Harish, so he can tell you a little bit more about these, and then I will come back to talk about other stuff here. All right,
Are you guys still awake? Yeah. Okay, awesome. So we'll see. So I'm not sure exactly what order the slides are, so I'm going to somewhat freestyle here. Okay. So since you're talking about advanced topics, I think if you actually see the list of topics, it's not really that much of a hodgepodge of different topics. So we probably should come up with a better name for this rather than advanced topics, and we probably will very soon, right? So before I get into all the future interesting technologies, I want to maybe start with a small background about myself, right? If you look at my dissertation and my PhD research, it will be on developing distributed algorithms for algebraic topology. Or in other words, I'm not going to talk about that, right? Right, so, but what I want to stress is the importance of learning, being good at math and learning a lot of math, because if you're good at math, pretty much you can do anything else, right? So let's see. So when I was actually in undergrad, my concentration, like my major was in electronics and communications, right? So that means I did a lot of electronics, a lot of DSP, and a lot of communications, right? And one of the things which I really loved when I did DSP is it was after my junior year, I was in an internship. You guys are not too young to know Walkmans, right? Do you know like CD players, Walkmans? There was a time in there, right? All right. So I was working for a company, right? All right. You guys are not that young, not babies, right? So I was working for a company where they were trying to, those equalizers which came on those CD players where you can control the bass, treble, and things like that. Right? I was writing a code to implement that in digital signal processing. Right? So it was pretty cool that when I was a senior year, one of the products out there was running my program. Right? So it was pretty cool. So DSP is so versatile because pretty much all processing now is done digital. Right? So if you learn digital, you can do this DSP, you can do a lot of things, right? So now let's go to communications, right? So pretty much, communication is, if you want to define communication, you just want to say take information from one point to another, right? If you look at our modern technology, pretty much everything deals with communication in one form or other, even computers. Okay, she's showing 2 minutes. I'm probably going to ignore that. Okay. No, I'll keep it. So my chair is here, so I will not ignore that. Right? Right. So when it comes to communications, let's think about what you may think, when you talk about cell phones or TV broadcasting or satellite communication, things like that. But pretty much everything else, even computers, there's a lot of communication going on internally, right? And many of the things you learn in your courses are directly, you will see, even in undergrad, many of them are actually quite advanced topics, but lots of stuff you learn in your undergrad courses are directly applicable, right? And there's a huge avenue of jobs and opportunities in this area. So some of the technologies that will be coming very soon is 5G technologies, Internet of Things, which is already being deployed, right? And 5G, if you listen to the talks in industry, they were talking, the 5G product will start coming out in 2020, right? But I would say you guys should think about in a much bigger picture, right? So much longer point of view. Let's say 20, 25 years from now, what will we be doing? But have you heard about Starlink from SpaceX, right? They're deploying satellites for terabyte internet on satellite, right? So as soon as deploying satellites becomes very, very cheap, you'll start seeing this huge amount of applications opening up in satellite business. And if you look up what we can do in satellites, there are already small companies which are launching small micro satellites which are doing lots of different stuff. And then once satellite launching becomes cheaper, there's a huge amount of applications come up, and all of them require lots of communication, right? And then we have internet. In the future, we will need something called SpaceNet, right? Because we have satellites around Mars, we have satellites around Venus, we have satellites around Sun. Maybe future we'll have satellites further out in the solar system. All of them need to communicate. We need to maintain a network. People will start mining asteroids. Right? So to maintain all of this, to maintain infrastructure, we need communications. And the way we do communications on Earth, in atmosphere and with all the surroundings and reflections, is completely different than the way you do communications in space. Right? So that will require a complete redesign and design from scratch of the entire communication system. And you guys, will be doing that. You guys will be practicing engineers when all this is being developed. Right? So think long term, and then, for example, if I say, hey, you're gonna develop 5G technology, that's not that motivating, right? We already have 4G. Come on, right? But if you think about you want to do space internet or SpaceNet, right? That's something you can be motivated to, right? So that's probably what I'm going to say here. So, yeah.
Thank you, Dr. Harish. So some of the big players, as I said, and most of these, they have either offices in Orlando or in Florida in general. And these are also potential employers for you: Qualcomm, Harris, Raytheon, and NASA, and all of these other guys here. So when you have knowledge in the topics that we mentioned, these are some of the potential or some of the big players here we have. How much can you make when you are an electrical engineer in these fields? And I have a sample here for you. So this is the median salary. This is based on the 2018 statistics. And here in the red box here, you can see some other types of engineers: RF engineer, which is microwave and radio frequency, telecommunication engineer, DSP, and other types of engineers. So you can see that you can make some good money here. And finally, just to let you know a little bit about my expertise, the courses I taught are systems and signals, circuits 1, circuits 2, satellite communications, RF, and introduction to radar. My research activities and interests, I'm a microwave remote sensing guy, so I deal with Earth observing systems and the microwave region. And I dealt with radar and radiometer, active and passive sensors in airborne and spaceborne environment. I am an image and signals processing, so if you have a satellite image or any image, we can do some features extraction and then line of sight sensing and things like that. And also now I'm involved in the autonomous vehicles, as I said, so especially for sensors testing, EMI, electromagnetic interference, and electromagnetic compatibility, and also in data fusion. I'm just showing you 3 different samples of my work. The first one is an algorithm that I built from data from one of the satellites. We call it Advanced Microwave Scanning Radiometer. And you can see this is for Hurricane Irma last year. And this is the color indicates wind speed. Warmer colors are higher winds. This here is the anechoic chamber, which is a chamber we are developing right now with the Advanced Mobility Institute to do some sensors testing for autonomous vehicles. One meets for me and my student, Michael Jernigan. And here, this is also another radar we are building right now. It's a simple radar that can measure speed and direction of a moving object. We are working on that, and hopefully we'll start using it for demonstration and some projects in our classes. All right? So that's it. I'm not sure if Dr. Harish wants to say more about it, but that's it. And if you want to know more about this, see me in room 1002. I'll be there. And if not, you can come to my office or email me. All right? Thank you, guys.